Welcome back, grade 10 students. This is teacher Hazel and I will be your math teacher for today. Are you ready for our next lesson? At the end of this video, you will be able to find the sum of the terms of an arithmetic sequence. Are you ready? Before we start our lesson, let us have some activity entitled Something. In this activity, we have a problem. And the given problem is, given the sequence 3, 4, 5, 6, 7 until 12, where 12 is the 10th term, find the sum of the terms of the given arithmetic sequence. In this problem, our goal is to find the sum of the terms of the given arithmetic sequence. Now let us try to find the sum of the terms of the arithmetic sequence. In the given problem, the given arithmetic sequence is 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. In the given sequence, we have 10 terms. One way to find the sum of the terms is by adding each of the terms. We have 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11 plus 12. Adding the terms gives us 75. But adding the terms take time. Is there a shorter way to find the sum of the sequence? Yes, there is. Observe that if we add the first and last terms of the sequence, which is 3 and 12, we get 15. And if we add again the next inner terms, which is 4 and 11, we get 15 again. The same thing goes with the next preceding terms. We get the sum of 15. Now, to get the sum of the terms given the arithmetic sequence, simply multiply the half of the total number of terms, which is 10, and the sum of the first and last terms, which is 3 and 12. Now we have an equation, 10 divided by 2 times the quantity 3 plus 12. Now, we know that if we divide 10 divided by 2 gives us 5, and 3 plus 12 gives us 15. And we also know that if we multiply 5 and 15, we get 75. Now the sum of the terms of the given arithmetic sequence is 75. What if we are given these problems? Find the sum of the first 10 terms of the arithmetic sequence 3, 6, 9, and so on. And also, find the sum of odd integers from 1 to 99. Will I be able to solve these problems given that I don't have enough time? Yes, of course, because today we will learn how to solve for the arithmetic series. Now, what is arithmetic series? Arithmetic series is the sum of the terms of an arithmetic sequence. If the terms of the sequence 3, 4, 5, 6, 7 are expressed as sum, this becomes arithmetic series 3 plus 4 plus 5 plus 6 plus 7. And if we add these terms, we get 25. The formula of the sum of the terms in a finite arithmetic sequence are the following. If given the first term denoted by a sub 1 and the last term denoted by a sub n of the sequence, we use this formula. S sub n is equal to n over 2 times the quantity a sub 1 or the first term plus a sub n or the last term. If given the first term denoted by a sub 1 and the common difference denoted by d of the sequence, we use this formula. S sub n is equal to n over 2 times 2a sub 1 plus the quantity n minus 1 times d. Let us have some examples. We have example 1. Find the sum of the first 10 terms of the arithmetic sequence 3, 6, 9, and so on. Now, in our problem, we have the given sequence 3, 6, 9, and so on. Now, from the given sequence, we have the given, which is the first term, we have 3. So we can denote the first term as a sub 1 is equal to 3. Learning from our previous video that the common difference is just a number added to the previous one to get the next term. So what number are we going to add with 3 to get 6? So the number that we're going to add to 3 to get 6 is just 3. The same thing goes with 6 and 9. We add 3. So we have 6 plus 3 gives us 9. So the common difference is just 3. Now also, in our problem, given is the number of terms, which is 10. So we can denote it as n is equal to 10. Since we have the first term and the common difference, we use this formula. S sub n is equal to n over 2 times the quantity 2a sub 1 plus the quantity n minus 1 times d. Substitute the given values to our formula. We have S sub 10 is equal to 10 divided by 2 times the quantity 2 times 3 plus 10 minus 1 times 3. Following the PEMDAS rule, subtract the terms inside the parentheses. We have S sub 10 is equal to 5 times 6 plus 9 times 3. Multiply the terms inside the parentheses. We got 27. And adding the terms inside the parentheses, we have 27 plus 6 gives us 33. So 5 times 33 gives us 165. So the sum of the first 10 terms of the arithmetic sequence 3, 6, 9, and so on is 165. Let us have another example. We have example 2. Find the sum of the odd integers from 1 to 99. Observe that in this problem, the sequence is not yet given. To answer this problem, we need to understand the problem first. The problem asks for the sum of the odd integers from 1 to 99. And we know that the odd integers are 1, 3, 5, 7 until 99. So from this set of numbers, we already have the sequence 1, 3, 5, 7 until 99 were given is our first term, which is 1, and we can denote it as a sub 1 is equal to 1. The common difference, we have 2, because if we add 2 to 1, we get 3. Also, if we add 2 to 3, we get 5. So the common difference is just 2. And we have the last term, which is 99. Observe that we have the first term and the last term. So based from our problem, we can use the formula S sub n is equal to n over 2 times the first term plus the last term. Now, observe that we need to know the value of n. So, since n is not given, we need to find the value of n. And to find the value of n, we need to use the arithmetic sequence formula, which is a sub n is equal to a sub 1 plus the quantity n minus 1 times d. Since we are finding for n, we substitute the value of the first term and the common difference. So, substituting the value of the first term and the common difference, we have 99. We get 99 here because our 99th term or the last term is 99. So we have 99 is equal to 1 plus the quantity n minus 1 times 2. Using the distributive property of equality, we distribute 2 to each of the terms inside the parentheses, and we have 99 is equal to 1 plus 2n minus 2. Now, adding the terms, like terms, so 2 minus 1 gives us negative 1. Now, add and subtract terms in which we want to cancel out negative 1. So, we add 1 to both sides and we have 99 plus 1 equals 2n minus 1 plus 1. Since we know that negative 1 plus 1 is just 0, and 99 plus 1 gives us 100 is equal to 2n. By division property of equality, we divide both sides by 2. So, we have 2 divided by 2 gives us 1. So, we have 1n equals 100 divided by 2 gives us 50. Thus, the value of n is equal to 50. Since we already know that the value of n is equal to 50, now we are now ready to substitute the given values, the first term, the last term, and the value of n to our formula. We have S of n is equal to n over 2 times the quantity at a sub 1 plus a sub n. Substituting the values of a sub 1 or the first term, the last term, and n, we have S of 50 is equal to 50 over 2 times the quantity 1 plus 9. We know that 1 plus 9 gives us 100 and 50 divided by 2 gives us 25. So, 25 times 100 gives us 2,500. Thus, the sum of the odd integers from 1 to 99 is 2,500. Now, do you have any questions? I would love to read your questions on the comment section below. Did you learn something? What have you learned? I would love to read what you have learned on the comment section below. Now, let's exercise that brain by having an activity. Are you ready? Then let's start. Now, let us find the sum of each of the terms for each of the following. Number 1, 6, 11, 16, 21, 26, 31, 36, 41, 46. Now, find the sum of each of the 9 terms of the given arithmetic sequence. Number 2, we have 10, 15, 20, 25. Find the sum of the 20 terms of the given arithmetic sequence. Number 3, we have a sub 1, or the first term is 25, and the common difference we have is 4. Now, find the sum of the 12 terms given the first term and the common difference. Number 4, we have the first term is 25 and the 10th term is 101. Now, find the sum of the first 10 terms of the given sequence given that the first term is 25 and the 10th term, which is 101. Number 5, last number, we have a sub 4 is equal to 41 and a sub 12 for the 12th term is 105. Now, find for the first 8 terms of the sequence where the 4th term is 41 and the 12th term is 105. That's it. I hope you learned something. Thank you for watching, and I will see you on our next lesson.